Hey guys, I hope you're in good health. Unfortunately, once again, due to the coronavirus pandemic, the midterms for this course as well have been moved online. So your next midterm will be next Tuesday, March 31st, and it will be uploaded online at 9 a.m. Nick has made sure that all tutorials taking place on that day have been rescheduled to Monday, I believe, to ensure that all of your colleagues are not busy on that day and can focus primarily on the midterm. So today's content, thankfully, is fairly light, and I'm confident that you guys should be well prepared for the midterm then, because based on the previous results, you guys have done fairly well, and I'm confident you guys will continue to do fairly well on this midterm. So now we'll shift on today's lesson. And let me go to the slides and I will make this full screen. Cool. So today's lesson is on the Matplotlib library. Matplotlib is an incredibly useful Python library that allows us to make graphs, plots, and other visual representations of data. The library is a prerequisite if you want to do any work at all with data analytics in Python. And the library is commonly used hand in hand with Numpy and Pandas and other data analytics libraries. Now today, we're not going to do anything too complex. We'll just do some basic, standard hello world matplotlib type questions that can be completed at the link found in the slides, and you can also find in the description and on Avenue. So we'll go there now, and I will turn off my video, but not my audio, hopefully. Awesome. So this is question number 1, and our goal is to make this plot in Python. We have to make Python code that will produce this plot. As you can see, it's a plot of a linear function. And I'm going to navigate to the YouTube channel just to make sure that it is live still. I hear my voice. That's good. Awesome. I hear my voice. That's good. Awesome. Cool. Audio is good. Okay, cool. All right, now we can make the Python code to produce this plot either online in this online web editor, or we can use our own Python local installation to make the code. Now I'm going to use the local installation to make sure you guys are familiar with how to set up Matplotlib in Python on your local computer. So I'm going to open up the Python IDE. I'm going to wait a few seconds because my computer is kind of slow. Now, once again, to make this graph, we'll be using Matplotlib. And Matplotlib does not come by default with your Python installation. You can check to see if you have Matplotlib or any library at all in Python by typing import and then the library name. In this case, Matplotlib. And because I have the library, this code executes without issue. Now, if I tried to import a library that I did not have, well, let's say I tried to import TensorFlow, it will throw up an error because I don't have that library. Fortunately, it's really easy to install libraries in Python. All I have to do is go to my command prompt. So type cmd and pull up command prompt. And just type pip install and the installation name, which in the case of Matplotlib is Matplotlib. And when I execute this line, it will check to see if Matplotlib is installed or needs to be updated. So I'm running the line, and because I have the latest version of Matplotlib installed, the computer doesn't do anything extra. So if you cannot install or get Matplotlib to work on your computer, that's totally okay. Instead, you can just use the online web editor. It's the exact same code for both. Now, I'm going to make a new Python program that'll do question 1. So I'll save this as question 1. Okay, question _1. And let's go back to our question to understand what we're doing. We have to make the plot as seen in this image. So the first step to making this plot is to go to our code and import the Matplotlib library. So I'm going to type import Matplotlib, but we only need one specific part of the library called pyplot. So I'm going to import just that part in order to save time. And because this is a very long name, I can make it easier to call the library in my code by denoting it with this variable called as plt. And now I can call upon the matplotlib.pyplot functions with just plt. Now the next step is to define the x range of values. So I'm going to initialize a variable called x, and I'll make that equal to a list that ranges between some range of values. On here, it seems that the x-axis goes from like 0 to 50, or just after 0 actually, to just before 50. So I'm going to go into my code, and I'm going to type x equals range 1 to 50. And this will produce a list that ranges from 1 inclusive to 50 exclusive. So my values will go from 1, 2, 3, all the way to 49. And after defining my x domain, I can define the y range of the graph. And once again, I can define it as a list where each value in the y range is a function of x. So to do that, it's very simple. I can just have, I can just loop through all the values of the x range, so for value in x. And so for each value, I can just do something to it. In this case, I can multiply each value by 3. So if my x values are 1, 2, 3, 4, my y values would be 3, 6, 9, 12. Each y value is just the x value times 3. So y equals x times 3. Now the next step is to actually make the plot. So to plot x and y, all I have to do is type plt.plot x, comma, y. And then I can show the plot by typing plt.show. Cool. Now if I run this code, well, there are some caveats, but if I run this code right now, oh, my bad. Once again, Python is case sensitive, so because my x values are with capital X, they have to stay with capital X down here. Cool. And as you can see, we've made this plot that plots our x and y values. The x values go from 0 to 150, and the y values go from the same range, well, the range for y. Awesome. Now, as you can see, we're meant to make the same plot that's seen in this image. And that plot has these labels, y-axis, x-axis, and the title, draw a line. So I can make those plots quite easily with those subtitles. So to make the x-axis subtitle, I'll just write plt.xlabel. And then whatever I type here is the x-axis. Likewise, I can type plt.ylabel, and whatever I type here is the y-axis. If I type plt.title, whatever I type in there is the title of my graph, which I'll just say is the same as the one we see in the photo, draw a line. And if I run this code again, it'll produce the exact same plot, but now with these labels. Cool. And that's question 1. Okay, so I'll give you guys a second to catch up, and then we'll move on to the next question. Okay, I'll check the live stream once again. I think I'll do that just more often just to make sure we're all good. Can I check it from here? Oh, cool. Okay, cool. The live stream seems to still be functioning. Okay, let's move on to question 2. So in question 2, we have to make the piecewise function seen in this plot. So keep in mind that when Matplotlib plots a line, it just connects lines from one point to another. So to plot this graph, how many points do we need to define? Can anyone say in the comments? How many points would we need to define? In order to define this plot? Yeah, 3, that's it. So I have to make, once again, a Python list with just 3 points. So to do that code, it's very similar to the last code that we wrote. And once again, I'll save this as, let's say, question _2. And I'll say it's import matplotlib.pyplot and as plt to reduce the execution time. And I'll define my x range and y range once again. So if x is, let's say, just pick the 3 convenient points, I think it's defined in the question as being at specific places. Okay, so it seems like it's 1 and 2 and 2 and 4 and 3 and 1. So if I go to my Python code, I define my x points as being 1, 2, 3, and my y points as being y part of the points being 2, 4, 1. 2, 4, 1. Awesome. And then to plot these points, I just say plt.plot x comma y. And then I can make my labels as need be. So plt.x label comma comma x axis and plt.y label comma comma y axis. And then I can define a title too. Let's just say, this is the title. Key thing is the concepts, which is what we have to understand. Okay, and then if I run this code, this will produce our graph. As you can see, we've made the similar graph. But this time we've said this is the title or the graph name. Awesome. Okay, I'll give you guys a minute to catch up, and then we'll move on to another question. Cool. Hi, it is 12:30 at night. Good night. All right. Yeah, 3 Nishan, exactly. Cool. Okay, any other questions? I don't see any questions, so we'll move on to question 4. Okay. So in question 4, we once again have to make this plot, but this time there's multiple lines that we have to plot, which makes it a bit more complicated. As you can see, these points here correspond to each of the 4 lines. Now, we absolutely could copy these points as lists in Python and then plot all of those points. That is a totally valid way of producing this plot, but that's kind of tedious, and I'm too lazy to do that. So instead, we can just import all of this data at once. And fortunately, there is a very easy way to do that in Python. So what I'm going to do is I'm going to copy all of this data, and I'm going to go into a text editor such as Notepad++, and I'll paste this code and then save it as a file. And any idea what type of file I should save it as? Any ideas based on how the data looks like? We'll save it as a CSV. So I'm going to put data, we'll call it data.csv because they're comma separated values. Cool. And then I'm going to save it in the same directory that has all of my other code. So let's go to Python 3.5. And then we'll save it in here. If there is not already a file called data.csv. And there is. So I'll save it as data_actual.csv. And now I can import that data in Python quite easily. Now to import the data, we need to use an additional Python library. In this case, we'll be using Pandas. So Pandas is another Python library that doesn't come by default installed in Python. So if you don't have Pandas, how can you easily install it? Using pip install, exactly. So I would do that by typing pip install and then the Python installation name, which is Pandas in this case. And that ensures Pandas is installed and up to date. Now I can write question 4. So I'll make a new program and I'll save it as question _4. And this time I have to import 2 libraries. So the first library that I'll import is I'll import matplotlib.pyplot, and I'll import it as plt to save time. And I'll also import pandas. And pandas is also tedious to type, so I'll abbreviate that as pd. And now I will import in the data. So I can do that by just typing in some initializing some variable. Let's call it db for data values. And in order to read the CSV, it's a Python pandas function. So I'll type pd.read_csv, and I'll pass in the appropriate parameters, which include the name of the file, which was data_actual.csv. And then I'll set the separator equal to a comma because it's comma separated values. And I'll set parse states to true. These last two values don't matter that much. I'll set the parse states to true, and I'll set the index underscore column to 0, in case there is like a column just for description. And then I'll plot this data. So db dot, I'll use the plot function, and then I can show my plot as needed. Then I can run my code. And there we go. And here's our 4 lines that we plotted. And we did not have to do any list making at all. All we have to do is import our data very easily as one file. So it took us about 8 lines of code to make just one plot. Here we've made a plot of 4 lines with just 5 lines of code. So there's definitely ways to be very efficient in your time with using these Python libraries. All right, and I'll give you guys another minute to catch up, and then we'll move on, and I'll check the comments. What did the comments say? Seems to be okay. So I guess we're all good. Awesome. Cool. And I'll move on to question. Let's do question 11. Okay. So in question 11, as you can see here, we have to once again plot multiple data points, but this time these points are not a solid line. We're plotting just the points themselves. So again, just a small caveat, there's not a big difference between the concepts that we're using. And we can do this with some NumPy. So I'm going to make a new Python program. And I will save it as question underscore 11. And I'm going to import 2 libraries once again. This time I'm going to import NumPy, which I believe does come pre-installed with Python, I believe. But if not, you can install it using pip once again. And I'll install NumPy as np to make it a bit shorter. And I'll import once again matplotlib.pyplot, and I'll abbreviate it by the usual plt. Cool. Now, in order to make these data points, as you see here, we're going to make them as a NumPy array. In order to make a NumPy array, I'm going to initialize some variable. Let's call it t for time. And I'll say numpy.arrange. And what arrange does is it produces an array between 2 particular bounds. So in this case, I can make my bounds 0 and 5, and I can make the distance between each bound, separation distance, 0.2. Now, because I want these values to be floating point, I have to add a period after each of the bounds. Otherwise, it would only do the steps by whole numbers. And now the increment distance will be just 0.2 at a time. So it'll go from 0 to 0.2 to 0.4 all the way to 5.0. And now all I have to do is make my plot, and I can plot all 3 lines just at one time. So plt.plot. And I'm going to plot my x values, which are t. And then I'll plot my first line, which is just a linear line. So it's going to be just t again. And I can denote the symbols using some particular nomenclature they have. So in order to denote green dashes, as seen in this image, these green dashes, I have to type G dash dash. Cool. Then for the second plot, it's an exponential curve. And we'll say it's going up by a factor of 2. So I'll plot t as my x values, and then t raised to the power of 2. And this time I'll denote them with some blue squares. And the symbol for blue squares is BS. Okay. And lastly, I'll plot my third plot. Once again, it's the same range. This range we've defined up here for the x values. So the domain for the x values is going to be t, and the y values will be t raised to the power of, let's say, 3. It doesn't really matter as long as you understand how to plot using Numpy arrays. And then lastly, our symbol. This time, I think they chose the red triangles. Yeah, the red triangles. And the symbol for red triangles is R, and then an exponent sign. And these symbols are just things that we can memorize in terms of the different shapes they have for NumPy and Matplotlib. And then to show my plot, I just type plt.show, and there we go. Oh, my bad. I think I imported it. Yeah, import NumPy as np dot. Just spell this. Oh, my bad. That's weird. Oh, sorry. Arrange. I spelled it wrong. My apologies. I'm not good at spelling. And there we go. We've made the required plot. And make sure to spell the function name right as needed. And as you can see, we have our 3 plots, one of green dashes, one of blue squares, and one of red triangles. Cool. And now we can move on to our last and final question for the day. But I'll give you guys one more minute to catch up as need be. And I'll check the comments. And we seem to be all good. And question 14, which is the last one that we'll be doing, is a bit tougher than the other ones. It's the same concepts over and over again, with just 2 caveats. The first caveat is we have to add the special grid in the back. And the second, slightly more difficult caveat is that the data we're dealing with is in type date. So it's strings that represent dates. Now the thing is that there is no data. We're not using any date type in Python. So we have to come up with some way to organize the dates as need be. Fortunately, there's a built-in way to do this with Python. Okay, now once again, you can make this code either in the editor or in either one is fine. It's the same result. So if you can't get it to work in on your local computer, you can just use the online editor if that's an issue, and we can start making this code. Cool. Unfortunately, this time they don't let us just copy the data, so we have to actually just read it off the graph. So we have one that's on 2016, October 10th, and that's 772.5. Then we have 2016, 10/04, the next day, and that's 776.5. And we're going all the way day by day to 2016, 10/07, where it ends on 7750. Okay, cool. So let us make our last Python code of the day. And then we'll save our program as question_14. Now, fortunately, there is a built-in library that we can use to process dates in Python. It's called the datetime library. So we can type import datetime, and once again, we generally abbreviate libraries as a smaller variable to make them easy to call. In this case, I'll abbreviate it as DT. And then I'll import the Matplotlib libraries as needed. So I'll type from Matplotlib import pyplot as PLT, and I'll import the dates aspect of Matplotlib too. So I'm going to type from Matplotlib dates, and I'll import that as date to num. Okay, so unfortunately, we cannot just copy all of the data into a CSV and import it that way. They've not been nice and abbreviated the data. We have to just read it off the graph, which is kind of tedious. So I'm going to declare a variable that I'll call, let's say, data. And I'll make that equal to a list where each element of the list is of the data, the date type. So I'm going to define this data as needed, and this is just kind of tedious, so you can skip over this part if you're watching after if need be. And each value is going to be called dt.datetime.strp time to strip the values. And then in that function, we're going to pass in both the data string, the date string, and how we want to interpret the date. So the first parameter is the date string. And for example, for the first day of trading of Alphabet, it is on 2016-10-03, and the value is 772.5. So I'm going to pass in my date value, which is 2016 -10 -03. And then I'm going to interpret this date string in the following way. The first parameter represents the years, so %year. The second parameter represents the month, so %m. And the third parameter represents the date, the day, so %d. And then finally, for each of these elements, we'll pass in the actual y value. Just make sure my commas are correct. So the x value is the date, and the y value is the trading price. Let's say it's 772.5. I can't read exactly what those values are, so as long as you can interpret them to be roughly close, we should be fine. Cool. And then let's move on to our next value. I think there are 5 in total. So we can just copy and paste them all. And then we're trading on each day of the week. So from 03 to 05 to 06 to 07. And we're going to approximate our values as need be. So based off of the graph, let's say it goes from 772.5 to, let us call that 776.4 to 776.5. So 776.4 to 776.5. It's not a big increase. And then let's say it goes to 776.8, 776.8, And then lastly, let's say it goes down to 775.1. So I'm not sure if these are the exact same values in the plot, but we're just approximating them just to make sure that our graph looks right. Okay, and based off this data, we can define our x and y range. So we'll say x is equal to, once again, a list, and that list has this for loop that we're iterating through. So for, it's a tuple of the data and the value in list data. So as we iterate through the list data, one tuple at a time, we'll say our value is date to num, which is the function we imported earlier on to process dates. And what we're going to pass in, we're going to pass in the date. And this is the x range, my apologies. Okay. And then likewise, we'll have a similar technique for y, but this time we're looking at the second part of the tuple. And so we're just going to take the value exactly as it is. We're not going to post-process it in any way. As we're doing to date, we're passing it into this date to num function. And that date to num function just makes it easier for us to manipulate the date in a plot. Okay, and then let's make our plot. So we'll just define it here. And we're going to define it with a variable name, just so we can do some post-processing on it. So we'll say it's equal to some variable. Let's call it fig. Let's initially, the variable is fig, as in figure. And then that's equal to plt.figure. And then to our figure, we can add the graph. So graph is equal to fig.add underscore subplot. And we'll add in about 111. And then we're going to plot the x and y values. And we're going to plot them with round markers. So once again, there's some specific nomenclature we have to know. So graph.plot, x values, y values, and then in terms of the marker, we want them to be round markers. So that's an O. And then the color is going to be, it's going to be red. So that's an R. And once again, this is just simple nomenclature we memorize with Matplotlib. It isn't a big deal knowing these specific nomenclature. Those are things you can obviously look up very easily. And there are some other things we can define too. These are just little caveats for things they wanted in the graph. So we can say graph.set underscore x ticks. That's turning the x ticks on for the x axis. And then we can turn on the labels too. And the reason why we want to turn on the labels is so we can have the values match the dates. And so I'm going to say graph.set underscore x tick labels. And then once again, we're just passing in a list. This time it'll be using the strip function. So I'll say date. So I'm going to iterate through my list of data. So for this tuple, date, value in data. And I'm going to manipulate which value are we going to guess. The dates, obviously. We'll just say date dot strf time. And we'll be just manipulating these values. So %y dash %m dash %d. And now it's going to show up correctly in our plot. Now we can just plot our data as need be. So Same code once again, blt.xlabel, and we'll make the x label title be date, be whatever string you like. We'll do the same code for the y label, and this time we'll say like trading price or actually the closing price, I guess. So closing price. And then our title, I think this is alphabet stock, so we can make our title name be plt.title alphabet stock prices. And then we can turn on the minor ticks too. And the minor ticks are just these faint lines you see in the background. So to turn those on, I just type plt.minor ticks _on with 2 parentheses. And then now I can manipulate these ticks. So in order to manipulate the ticks, I once again have to just change specific attributes of the plot. So plt.grid, which equals 2 commas, major, and then line style. And line style, you can choose a whole bunch of things. If you want it to be like dashes, well, we just type in a dash then. And then the line width, again, these are just attributes you can define as you feel fit. So we'll pass in 0.5. And the color, what is the color? Color is red. Once again, a lot of red. Is that good for stock prices though? It's not the best color. Okay, now we can define the minor lines as need be. So minor, and the line style, if you want it to be like dots, as it is in this case, you pass in a colon. And the line width, I guess we can just keep constant, but the color we will change to, let's make it black. That's a better color for stocks. And then lastly, we have to define the tick params. So I'm going to type plt.tick_params. And then I'll type which. This is for both. So we're changing both the major and minor. And I'll say all the values are equal to false. So it's kind of pointless, but we'll define it anyways. We need to manipulate it, need be. So we're setting the bool value for all of them false. Once again, bool is true or false. Right, that's equal to false too. And bottom equal to false. So top, left, right, bottom, all set to false. And now, finally, we can show our plot. Okay, let me just check the comments really quickly to see if there are any issues. Are we having any issues? Okay, I think everyone's good. Cool. Okay, so we can run our code now. And once again, these are not the exact same closing values, but I think it should kind of teach us the same concepts though, so we should be fine. Now we can run our code. And as you can see, we have the alphabet stock prices. Now, I've reiterated, these are not the exact same closing values. They might be a bit different in the actual plot, but it's the same concept though. All right. And those are the questions that we're supposed to get done today. As I said, next Tuesday, you do have, turn off my screen now, sorry. Now, as I said, next Tuesday, you do have your midterm for this course. It is the final midterm and it is online. So make sure to study hard. In terms of practicing Matplotlib, all I really recommend is going on to the same website we went before and then not only doing some of the questions, but playing with the questions, seeing if you can manipulate the plots as needed and adding in interesting aspects. I do apologize, as today there's not too many technical things going on, not too many logical things going on. It was just a lot of memorizing specific functions and then using those functions as needed, which is not always the most fun thing, but being able to make these graphs in Python can be incredibly useful. So in terms of practicing, I would just check out the Matplotlib questions if need be. And beyond that, you should be ready for the test. I will see you guys next Monday. And I think your classmates will also be watching tutorials on Monday too, because their tutorials will either be preponed or postponed so they don't conflict with the test. All right, if there are no other questions, I'm going to sign off then.